Hello and welcome back to the Hyperthesis. We are now in episode 65, the year end episode. My name is Feely.
I'm Patrick.
And I'm Liam.
Well, as 2023 comes to the end, so this episode is gonna be released, I think, on the 29th. So we're gonna have a little bit of a year review, see what are the physics breakthrough or important topics that we discussed this year or any miscellaneous things that we want to talk about. So, anyone want to start?
Well, I have a number of things to talk about that's kind of in the realm of a bunch of different science things. And I know Liam has a little bit dedicated to physics, but there has been a lot going on in the entire science community throughout the past year. I'll talk about a couple now, and then we can come back to some other things later, because it's quite an extensive list of things that we haven't really talked about before, whether they've just kind of slipped through the cracks or they weren't hard-hitting news, like some controversial topics such as the LK99 superconductor or discovering these very widespread ripples of gravitational waves throughout the universe. There's been a lot of smaller things that have happened, along with a lot of bigger things as well.
I think the second part after that, we should talk about our favorite discovery this year. Let's see what are our favorites.
Agreed. Before we get into that, I'll start with a couple topics. The first being about climate change, just because that's a topic I'm passionate about. But there's been a lot going on with it this year. A lot going on with global warming, as you may or may not be able to tell if you're in the northern hemisphere or southern hemisphere, along with a lot of interesting and some positive news as well. So things like emissions reductions and El Nino and other phenomenon have had major impacts worldwide. And so some announcements to start off. Start with the year in review, and that's 2023 in general, and the fact that it's most likely going to be the hottest year on record since we began measurements in the 1850s. So this is in large part thanks to El Nino, which is something we've talked about before. It's the El Nino Southern Oscillation, or ENSO. You can go search through our past episodes to find where we've talked about it. But essentially, it's this warming region of the South Pacific Ocean off the coast of South America. And this causes changes to the climate globally, whether for a year or for a couple of years. And it swings between this El Nino, a neutral phase, and then a La Nina phase. And this is actually the perfect time of year to talk about because El Nino was discovered kind of around Christmas time, and it usually happened around Christmas time. So it was named El Nino after the boy child who was born around Christmas, Christ. But it's, again, having global impacts. And this year we do have an El Nino. We were in previously La Nina years, which means it's a little bit cooler on average, whereas this El Nino year has caused temperatures to soar. And I don't know about you guys, but in Alberta, it gets very cold here, typically. But it's December at the time of recording. It's 2 days until Christmas Eve. And we are still getting plus temperatures here, which is unheard of in my region of the world, at least. And I know this is something that's happening at least in Western Canada and most likely other parts of Canada where we're seeing warmer than expected temperatures, and it's a lot drier, so we have a lot less snowfall.
Well, I think one of the things people do here in Canada is go skating on the river, and usually it would freeze over around this time of year. But I think some of the river have no chance of freezing or being frozen at all. Where I am now has a river and it's -6 outside, and I don't think it's frozen. People go skating, I think, from like from if you were in Kingston, you can go from the mainland to the island, just cross. But I think it's not happening now.
Yeah, the same here. Skiing is very big in Alberta, and even within Edmonton, which is relatively flat, we have a river valley with ski hills in it. And every time I drive by one or take a train by one, they're making snow at night because there's not enough snowfall being produced naturally, so they have to make snow. And that's a whole other thing we could get into in a future episode. Snowmaking is really interesting, and we've talked about snowflakes in our most recent episode, but yeah, it's very interesting to see.
I'm going skiing in a few weeks, and I think it's going to be a lot of human-made snow, unfortunately. So I'm interested to talk about that in the future, actually, because I don't fully know how it works. I mean, I assume you just shoot water out of a pipe and freeze it as it comes out, but probably a bit more to it than that.
Definitely. We should definitely explore that later. But going back to the lack of snow, this is going to have profound effects in the next year because if there's less snowfall, there's less snow melt. And snow melt can cause problems. Typically, it can happen relatively quickly, where almost all the snow melts within a couple weeks, and that leads to a very large influx of water into different watersheds and ecosystems. However, if there's not a lot of snow, there's no longer a lot of meltwater, which has many effects. So one of the major ones, especially in Canada, is fires. And so if you have less snow, you have less water, you have drier conditions, which means you're starting the year off on a bad foot in terms of fires because it's going to be a lot drier already. And this will just exacerbate the amount of fires that have happened. We already saw a record year of fire in terms of coverage and severity in Canada, where we've just shattered every other record that we've had. Like, it's not even a comparison, really. The fire season has been terrible. You can go to an episode from, I believe it was May or June, where we've talked about fires, but the fire season is predicted to be quite bad this upcoming year in 2024.
Well, I think one of the concepts in science that applies here is that the concept of open and closed system, right? Usually we think of closed system as like controlled in the lab in a box, but in a way Earth is like that because not that many gas or material leave Earth. So it's like a closed system. So if it rains somewhere, it took water from somewhere, right? So like if there's more energy in certain time, well, there might not be more in the future or in the year. Well, it's not exactly close because we have energy from the sun. That's where we get them, right? But in terms of like weather and climate, the water is almost a constant volume throughout the world if you think of it globally. So if it remains more in certain area, the other ones have to be a drought or something, right? So I think it's very important to, like you point out, that well, if it rains more now, we might not have a wet year next year or something. The time scale is quite long.
Exactly, yeah. And that's what a lot of these climate models have to consider is time scale. So, for example, with El Nino, it's a lot warmer in the Pacific, you get a lot more evaporation, and it's quite wet in parts of Southeast Asia. So you have more intense monsoon season and rainy periods, whereas in Western Canada and in kind of Western North America and a decent portion of North America, you get a lot drier conditions because of the same mechanism but different effects. So transitioning to wildfires, we had a record year of wildfires. So there were fires in Alberta, British Columbia, the Northwest Territories, Nova Scotia, Ontario, and Quebec. Nova Scotia is on that list, which it usually is not. It's not very susceptible to fires, but this year there were 2 major fires. And as of October 6th, 6,551 fires had burned. about 184,961 square kilometers, which is an incredible amount and amounts to about 5% of the entire forest area of Canada burned just this year. That's a very lot. Yeah. So this is about more than 6 times the long-term average of about 27,300 square kilometers. And there are still wildfires active. So again, with less snow, there's less fire suppression going on, where wildfires that started in the summer continue to burn, whether in the roots or just very slowly burn within the remnants of a forest. It's not being put out as thoroughly as it would if we had a high snow melt. So again, kind of doom and gloom for next year, but there's probably going to be a lot of fires next year, partially caused by fires that weren't fully put out this year, which we'll see how that goes. But this was certainly a record year for fires, again, shattered all other records. Now, moving on to my final item, this was an interesting article I read from the Environmental Protection Agency, or the EPA, which is an American agency that's responsible for environmental protection and monitoring many things to do with the environment. We actually had a guest on our show earlier this year talking about how different emissions can be monitored, especially from different plants and everything. You should go listen to that episode. It was very interesting. Yes, Emma McNeil. That was a very interesting conversation. And one thing that we measured the emissions for quite strictly are vehicles. And so technologies that have been introduced to vehicles, especially in the model year 2022, because things take a while to catch up. So we're looking at the 2022 year at the end of 2023. But technologies that have been implemented in vehicles to improve fuel efficiency have actually had an effect. And vehicles overall have never been more efficient. In fact, in 4 of the 5 categories, or it's 5 of the 6 categories of vehicles within the United States, all that they have been shown improvements in terms of fuel efficiency. So overall, within the United States, for cars in the model year 2022, carbon emissions have been reduced by about 10 grams per mile, or about 6.2 grams per kilometer. It's kind of silly they mix grams and miles, but it's America, so whatever. And this is actually quite a large jump. It might not seem like a lot, but if you're driving, for example, 100 miles in this case, then that's a whole kilogram of carbon dioxide that's being saved. And a large portion of this effect is due to electric cars and hybrid cars. So we're seeing a increase in electrification and in these hybrid vehicles that are lowering fuel emissions quite significantly. And as legislation, such as in Canada, we just passed legislation that any new car starting in 2025 has to be electric, which is very exciting and is similar to other policies implemented worldwide, but it's stuff we have to do. It may not be soon enough, and we even had a giant conference, COP28 this year, which was trying to come up with global resolutions for climate change. You can argue about the effectiveness of them, but we also had some pretty resounding statements, especially for a global organization and meeting from that. So there's a lot of progress. Is it too late? Is it too little? That's for a different conversation on a different podcast. But in terms of the science, electric vehicles and hybrid cars are helping improve the amount of carbon dioxide being released into the world.
Well, I think it's in the city is good, but like right now I'm like out of nowhere, right? Like imagine there's like nothing around for hundreds of kilometers. I think that's a different condition. So
I mean, so I drive an electric car, and they're plenty capable of going far enough. Like, it depends on your situation. If you're out in the country, you need to drive like 300 kilometers to get to town, then you'll just need a different one than a city driver. And I drive mostly in the city, so I can't speak for the experience, but I do know people that live way out in the rural Alberta, and they have electric cars and they make it work.
I see that, Patrick, you've provided a link on 10 breakthroughs in 2023, or someone provided a link here. Maybe it was Feely.
Oh, I did.
So it's 10 physics breakthroughs, and I just looked through it quickly, and I saw two of them. Well, I saw a few of them. That some of them I think we've talked about before, actually. Like there's like a double slit experiment in time, which is, I don't know if we talked about that, but I remember reading a bunch about it when it came out. But there's one of these 10 things that's simulating an expanding universe in a Bose-Einstein condensate. Was one of the breakthroughs of 2023 that this website published, which is interesting because
I knew you're gonna pick the BEC topic. I saw that, but I go to the link. I was like, Liam is gonna talk about this.
Yeah, well, I didn't see it until just now, so I don't have anything ready. But
oh, I know, but like one thing he's gonna pick from this article is the BEC.
Yeah, of course, because that's my research field. So when I went to these two conferences this summer, the one at Perimeter Institute and the one in Italy, this guy Marcus Obathar, who's directly mentioned for doing the experiment of this research, he was there, and he's friends with my supervisor, and my supervisor was just visiting him in Germany the last few weeks, actually. Well, partially visiting. I think he visited a bunch of different people. But anyway, yeah, it's a big thing now in my field. So I study analog gravity, where you can make things that mimic black holes, but it turns out you can make things that mimic our theory of inflation and study them. So that's what they're doing, and I just kind of want to point that out and say it's interesting. I'm not going to get into it too much because there's like a whole bunch of things, like, there's tons of papers published every day that you can talk about and say like, oh, they're all useful, or maybe only half of them are. But the other thing in this article that you put here was that antimatter does not fall up, which I don't know if that's something we talked about a little bit. But Feely, when you and I were at Waterloo was it a month ago, 2 months ago? I don't even remember anymore. It was fairly recent. We were judging, actually. We were judging a bunch of undergraduate research talks and posters, which was really fun. And I think there was one talk that was really good that I liked, and it was a student, and she talked about this experimental project she worked on where they directly measured the gravitational they have an antimatter particle, and they measure how gravity affects it. So if you ask a theorist, they'll ask, how does gravity affect antimatter? You just say, well, it's matter, so it goes down with gravity, right? Like, there's no controversy there, because the only thing that's different about, like, say, a positron, which is the antiparticle of an electron, is that its charge is opposite. So instead of having negative charge, it has positive charge, but everything else is the same. So of course, you'd expect an electron to experience gravity, or the positron to experience gravity the same way an electron does. But I don't think that actually been ever experimentally confirmed until this year, which I was kind of surprised at. I was like, oh, like, okay, everything we've been basing all this theory on for so long has actually never been experimentally verified. But I guess it makes sense, because antimatter physics is this kind of emerging field, because antimatter, if you have a antimatter particle, the moment it touches a matter particle, it annihilates into energy. So it's very hard to create them and keep them stable. So I guess they're able to do that now. So they basically made a big long tube. They put some kind of antiparticle in it. It might have been like an anti-helium or hydrogen atom. I don't remember from the talk, and I haven't read this article, but I just see it's here. And then they measured, well, it does what you would expect. It goes down exactly as gravity predicts.
Well, one of the thing is that I think most of the high energy particle were controlled using electromagnetic system, right? And usually they go pretty fast. Like the particle shoot out. It's not like it's created and it's just sit still. And to measure gravitational effect from where there all the electric and magnetic fields kind of difficult.
I think you can, with atoms, you can pretty easily trap them so that they're relatively stationary. They do that in I mean, I say relatively stationary, depends what their temperature is. Like in ultra cold atoms, you trap them all the time. You make like lattices of atoms and you do all kinds of things, but maybe when they're not ultra cold, they probably jiggle a lot more.
Yeah,
And
and also they must be not very stable, right? So trapping them, they might just disappear.
So, just for a little bit of background for people listening, we're talking about the anti-hydrogen laser physics apparatus, or the alpha G collaboration, because they're
mhm,
trying to measure the effects of gravity on anti-hydrogen.
yeah, well, I
But
think they did, right?
well, they did. It's not statistically significant, but I actually know someone
Oh,
that worked on this project. She's at the University of Calgary. Her name is Pooja Wuseri, and she was actually working on the trap for the anti-hydrogen, because this is a complicated problem of
mhm.
how do you make sure your anti-hydrogen stays within the trap without touching the walls, and then is able to essentially be settled enough for the free fall. So I remember seeing a presentation of hers at a conference about 4 years ago now, but it was very interesting because there's a lot of complex dynamics that go on within the trap, let alone the rest of the experiment, and trying to measure how fast antimatter drops. But it's exciting to see that they actually got a result.
Yeah, so I just wanted to point that out because I think, I mean, I don't know if I'm allowed to say this or not, but um, the talks that we were judging, the the woman who gave her talk on um the work she did on this alpha collaboration, I think it was the only talk I gave a perfect score. It was a wicked talk. And like you think of it like it's a pretty simple concept. It's like, does antimatter go down? You know, if I'm holding a ball of antimatter and I let it go, does it fall? Like Newton would predict, right? But it turns out the physics and the even like the her project, I forget exactly how it worked, but it was a lot of like machine learning and stuff like that to help like analyze the data and help like optimize things in the experimental setup. So even just doing a simple experiment like this, because antimatter is difficult, you learn a lot about it, a lot of different things. So I just wanted to point that out. So I thought that was pretty cool.
Also, just going through this, it's a Penning-Malmberg trap for anyone interested. And that's actually where
Ooh.
they create the anti-hydrogen by shoving in a whole bunch of positrons and antiprotons. And then it uses kind of an octopole magnet that's able to radially confine everything. And it uses a concept known as a magnetic minimum to trap hydrogen because it's technically neutral, in terms of being electrically and magnetically neutral, except for like those weird moments. But it's a very complex trap. But for anyone interested in looking it up, it's a very cool system, and it's a very complex system.
Dealey, did you have any select topics?
Well, I think I could talk about my favorite discovery. So I think this one is kind of spans multiple year, right? Well, even though I'm not an astronomer, actually I really like the James Webb telescope. And when we talk about that, the redefining the age of the universe, because I think that is such a what's called monumental thing to do. Because I think we believe for quite some time now about that 13.8 billion years thing.
Yeah, I was gonna honestly, I was hoping no one was gonna ask me what my favorite discovery was because I was just gonna go with the basic answer that everyone else has and say the James Webb Space Telescope being able to. It's not one discovery. It's like probably thousands and thousands of different things it's discovered because the James Webb is huge, right? Like such a big
Yeah, but
deal.
that's the one I care about. Because
Yeah.
the galaxy formation and stuff, and you leave that job to astronomer. But the one fundamental change that come this year that and it's also that paper was written by the guy at U Ottawa too. It's just right close by, not far away. So that's pretty good. And it really make us rethink about things, right? Does that mean the Big Bang happened much earlier, or also is this a Big Bang model still a good candidate? I think it's still good, right? But well, then also it implies that this is also a kind of early result, early on in the development too. Perhaps it's not true. Perhaps we will find out something more that really change our understanding or where we are in the universe. I guess for human beings, 13.8 billion years or 26 doesn't change anything much for us, right? But it's really, doubling is quite a strong change. It's a lot. Instead of just, oh, it's off by a million years or a billion years. This is off by twice the amount. So I'm not sure really. I'm excited to see what comes next year and further on, if there's more evidence or the evidence to the contrary, which gonna. I think it's good to know where we are in the universe or when we are, even though I don't really believe in time. Haha.
Yeah. Well, that's a whole debate, but yeah, it's just I find it so cool when I watch a lot of YouTube videos, as I say all the time, but you see all these like astrophysicists and astronomers and cosmologists, and they're just like so excited by all this James Webb data. Like it was one of these things that people made predictions when they first sent it out. They made predictions of what they would see, and they said we'll probably see this, but if things are pretty wild, we might see all this other stuff. And then everything that James Webb has been seeing is just like far, far beyond what anyone could have ever imagined it would see. So it's just shattering so many notions of our universe and stars and galaxies and just everything. So as far as I'm concerned, it was probably, I mean, maybe not the most immediate useful thing on the planet. They didn't cure cancer or anything, right? But it's probably the biggest deal as far as science is concerned, for me at least.
Well, I think, people sometimes forget that it's not just for the results that really matter. It's the development of the equipment, right? To
Yeah.
be able to understand radio telescope or be able to capture signal from outside the Earth. The technology we develop actually further our understanding into light and radio wave, or maybe X-ray, maybe different type of electromagnetic field, and those has tremendous applications. Most of the things, actually, a lot of things we use in medical, in for doctors like MRI and stuff, they weren't developed as the medical tool, right? So I think it's really good to have this library or like a catalogs of techniques we can go through to probe different parts of the universe. And we are part of the universe, so our body and such can be probed using these techniques too. Some of them are not very safe, right? So that's why we don't use them. You don't want to blast people with gamma ray. So I think there's a distinction between medical application and scientific research. But I think it's very, it's excellent that we can fund research that really just look outside to away from Earth, that still have an impact to daily human life. Because there are always this debate, right? Oh, if your house is still messy, and you what's it called, you haven't figured out how to live your life, why do we look at the stars? And I think it's a pretty okay critique that we should get our human affairs in order. But I would argue that looking at the stars is one of the most human thing we do, because animals look at it and probably just look at it, and we actually contemplate and ponder about where we are. I think that's what makes us very, very human.
Yeah, the long-term goals give you a reason to sort out your short-term goals. That's the way I think of it, at least.
So, Patrick, do you have any favorite topic or discovery breakthrough?
I mean, I have a list of discoveries made in the past year, but in terms of my favorite breakthrough, I found out this was actually last year around this time that it was announced but I'll just include it in this year because it was so late in 2022. But it was the fact that we had net positive fusion reaction. So from we've talked about this before, but there was a laboratory
Yeah. I think
that
it
was
was
able to.
the Edward DeWitt episode. We probably talked about it.
Mhm.
I don't
But-
remember, but I'm gonna guess it was that one.
And I think we talked about it when it happened as well. Around December 13th, 2022 was when it was announced, but again, I'll include it in this year. But the fact that we had net positive fusion reaction based on lasers essentially squeezing the fusion components together is super cool, but super hot. And I think is quite a profound discovery, especially fusion reactors have been around the corner for the past 40 years, 50 years, since the time when we had like a very strong nuclear age. But I think actually having these results and seeing the number of reactors that are coming online is extremely, extremely exciting.
You've got a big list of things here.
I do.
We should talk about one of them. I see here that the Einstein tiles. I don't know if you have any comments on that. Feely always thinks about Penrose tiles when you mention Penrose, so this is kind of like a conversation around that.
Yeah. So just for a little bit of context, we know Penrose tiles are a set of tiles that can be pieced together and have a non-repeating pattern over infinite 2D space.
Think like tiles, you mean just like two-dimensional tile, like floor tiles, right? Except they have specific shape.
Exactly, yeah. So
Yeah.
they're tiles that have specific shapes. It tends to be, I think, about 2 tiles that you can piece together. But as you piece them together, they don't form any patterns. Unlike, say, a subway tile where you have this very regular grid-like pattern or hexagonal tiles. Instead, these do not form a pattern at all, and just everything is unique about their arrangement. Now, a problem that we've had for about 50 years is, can this be done with only one tile? And the answer now is yes. And these are what are being called as Einstein tiles, where in this case, it's a 13-sided shape, and it's a single shape, but if you piece it together and fit them all together, they do not form a repeating pattern ever. So it's the same concept as a Penrose tile, but instead of using multiple different tile shapes, mind you, it might be like 2 or 3, this one just uses 1. So this was finally cracked, and so now we can have just a single tile repeated over and over, but never repeating the same pattern or orientation.
Interesting.
Yeah, and I wrote here, we'll see if any toilet paper companies try and use these, because there was a whole kerfuffle with the toilet paper company using the design of Penrose tiles so that they can...
What?
Okay, this is a very interesting story, but essentially a toilet paper company, I don't know which one, used Penrose tiles for their quilting pattern. And this was to prevent overlap between the little seams within toilet paper that's quilted to prevent essentially lumps, so that that way they could fit more and produce more in a roll without, but by avoiding these lumps that are formed by overlapping seams. So, but since Penrose tiles don't have any pattern to them, it's all unique, then the chances of these seams overlapping were very near 0. So there was a lot more that you could pack into a toilet paper
Oh my
roll.
god, Roger Penrose sued the company.
He did, yeah.
He had a patent on the tiles, but it expired, I guess. But he's apparently, I'm just reading this article, he tried to sue them, and I don't think it went through, but the toilet paper company just stopped using it, I guess, when he did that.
So it will be...
That's weird.
I'll be curious to see if Einstein tiles are used.
Yeah, I'm sure. Well, it's interesting that this is such like a like this kind of abstract mathematical thing, and like toilet paper companies are like, oh, we can use this. It's like how in the James Webb Space Telescope, was it James Webb? I know in different space telescopes they really use like origami nowadays to the art of origami to like better optimize how their mirrors and dishes and things can fit in smaller spaces before they unfold. So it's like one of these, it's some weird thing that you would never guess has like a proper application, but it does.
Well, the Einstein tile, it feels like, when you think of the concept of irrational numbers when we were young, it's kind of hard to understand, right? That's like, well, how come it's just go forever and just never the same or never repeating? And this is more like a geometrical version of that. You think you will see a pattern, but there's none, right? Or it just doesn't repeat. It's kind of hard to wrap the concept around because things we build usually are repeatable, right? Because that's make the manufacturing process easier, and everything has some patterns to it. Even your house, your door, everything. Even trees. You cut the tree up, you see the rings, right? The tree rings. There's some kind of pattern to it. So this is kind of a manifestation of what's it called. Well, it's predictable still, right? But it's still disordered. That something that be truly disordered, that you can't really have patterns on it. So that's quite interesting to see. So I think the next thing I want to move on to is that apart from the year review of science, I think you should talk about the real year review of us. What is our year? What do you think of this year so far? Well, I guess I can start. Well, this year I think for me is very tumultuous. There's a lot of significant changes that happen, and I would say it's not the easiest year. It's been quite difficult.
You became an alchemist, I've heard.
Yeah, I became an alchemist. So this well, this probably I should explain so it doesn't discredit my entire scientific career.
Yes.
I'm not trying to turn copper into gold or anything, unless no, not really. So one of the thing we do in our group is called digital alchemy, where we can change the microscopic structure of the material, or like of the particle, and try to understand the microscopic structure or properties of the material. Or we basically inverse designed material by having a property and try to create a shape that's optimal for it. So our method is called digital alchemy. So in a way, I've become an alchemist. Not Full Metal Alchemist yet, but
not
it's good
the
enough.
Isaac Newton version.
Yeah, so I basically changed my direction of my research a bit. Well, quite a bit. It's still in the same similar field, but it has not been the easiest. And it's a lot of work to do and to be done in the couple years going forward. Apart from that, I got to help butcher the deer yesterday in keeping with the Christmas spirit. So that was good to see exactly how to how it's cut, how meat is prepared, and take out all the apparently the venison fat. Venison fat is not tasty, so we had to cut a lot of that out. And I've been loving when there's nothing around or very little civilization around, because living in Kingston is a city, I guess. It's a small city, a city nonetheless, and it has its quirks, right? I think it has good part and bad part, but I really enjoy the country.
We should for our 100th episode, we should all go to a cabin somewhere and do the recording, like somewhere in like northern Ontario or Alberta somewhere. I don't know. That'd be fun.
Well, the other things that I did was a couple conferences, right? The APS March meeting in March in Las Vegas was very eye opening. Well, not because it's Vegas, but because the amount of research I get to see, the different various fields, it just blew my mind, because I didn't. Well, we have some understanding how big physics is, right? But being able to be in a place where they claim to have about 10,000 or 8,000 physicists, and all these hundreds of talks going at once, and they're top people in their field, and get to see big collaboration in multiple fields of research. And it's not even all of it, right? They have April meeting for different fields, and March meeting has a lot of condensed matter with biophysics, and it's just a I just felt like a frog in a well. Even though Canada is not that well, it's not that big, right, in the population compared to the United States. That's why the let's say the CAP Congress is much smaller, and even though it's still is a good conference, but the sheer scale of it is just was quite unbelievable to me. And yeah, I think that's like most of my time this year spent doing a lot of research and thinking about things. So it's not too bad after all, looking back. Anyone have any take on their year?
Let me think. I feel like I'm just doing the same old, you know. I'm learning, I'm researching, I'm trying to travel as much as I can to these conferences in other parts of the world. So I went to Italy and I went Nova Scotia at one point to visit my family, and I feel like there was some other place I went, but I can't remember now. It's all a blur.
How
Um,
about your bagpipe journey?
my bagpipe journey. Yeah, so the way the, the whole of the bagpipe journey. So I'm in a band, the Guelph Pipe Band, and it's a competitive band. So the way pipe bands work is that grade 1 is like the top tier of your players. So grade 1 pipe bands are the best, and then grade 5 is the lowest. So grade 5 is like you're new to it. You're new to competing, that kind of thing. So our band is grade 3, so we're kind of smack dab in the middle, and it's not like a linear increase. It's not like they're all the same step size away from each other. Um, Probably like, I mean, I don't know. I'm just gonna pull a bunch of numbers out of thin air, but like 70%, 60-70% of bands are grade 5, and then 10 or 20 or maybe like 10 or 20 are grade 4, and then so on. It gets smaller and smaller and smaller up until grade 1. But our band this summer, we won the North American Championships, which is really fun. That was my second time winning it, because the first time I did it, I was with another band and we won grade 4. So this year we won grade 3, which is really fun. And we're going to Scotland this summer to compete at the World Pipe Band Championships in grade 3. So that'll be like a really good learning experience for when I go there in the future, hopefully, with other bands or the same band. Who knows? So if we do well there, then we'll move up to grade 2, and we'll see how that goes. But yeah, I've been loving it. Although the last month or two, I haven't been playing near as much as I should be. Unfortunately, I've been so busy with work, and I moved, and it's been a whole
Yeah,
process. But
I'm similar, right? Because I mean, I'm not doing it competitively, but I just picked up my guitar again like this week, and I just realized how much I haven't played. Even though from time to time I pick it up to just like go through old repertoire, so just to have that refresh my muscle memory. But I just didn't learn any. Well, actually, I learned a couple pieces this year, but not as many as I used to, and maybe because like when you spend the day learning something like research, it's really hard to me to like exercise my brain again in the evening to learn more pieces. It's getting more and more complicated, because now I don't know if it's the same with you. Every time I try to learn easy pieces, just like it's kind of boring. I'm doing this for fun, and if it's boring, is it doesn't feel that good. So yeah, I've been trying to learn more complex pieces, which actually use a lot of brain power. You have to figure out the fingering. You have to figure out there's specific techniques you need to use for certain parts, certain sections, and it's actually pretty involved, right? So I'd rather just sit down sometime and just read something, read a book. It's much easier to do.
yeah, I feel the same way. Like you get home from researching all day, and the last thing you want to do is learn music, I find. So like that's partially why I haven't been playing as much as I should. And I'm still playing like every day or two. So I'm still playing like 30 minutes a day probably, but like should be an hour, honestly. Um
And a
yeah,
bagpipe is a louder or more pronounced instrument too, right? And
Yes,
you're
yes,
lucky now. You're
definitely.
living with someone who loves bagpipes.
Yeah, yeah. The place I'm living now, I can practice whenever I want, which is incredible. But somehow, because of that, I've been playing less. Because I guess before I had to travel to all these places to do it, so I would get on a bus and go there. And once I'm there, I'd be like, "Ah, I'm here. I might as well play for an hour." But now that I can just, they're like sitting over in the back there on my couch. I could like, I'll get them later, and the next thing you know, it's 10 p.m. and I'm like, oh, I don't really want to play them now. So I
Well,
think
as
I
they
have
say,
to,
people
yeah.
people who arrive to school late, they are usually the ones that live the closest, right?
Yeah, so I think in the new year I'm gonna be well, not even the new year. I think starting tomorrow I'm gonna make a schedule and stick to it because right now I don't really have a schedule. I'm just kind of flying by the seat of my pants, you know. So
So Patrick, how about your year?
Well, this year's been interesting, and if I had to put a name to it, I would say it's the year of connections. Just because I'm more established in my field now, and I was able to travel a lot to meet people and do different things related to my field. So in January, I was able to go to Germany and work with the German Space Agency, along with a couple other institutions there and universities, which was really cool. And then I was also able to do some field work in Costa Rica, got some actual results for and data for my own research, which was nice. And then also attended a conference in Montreal on biodiversity, which was really cool, and it was a great way to meet people. So I would say this was not as productive a year as I would have liked in terms of research. I'm now starting to ramp up production of code to do analysis and then starting to write as well. But it certainly was a good year for learning and making connections and meeting people in the field. Um, yeah, and then I also worked for the Canadian Forestry Service for the summer, so that was also a good experience.
that's pretty cool. You got to do all that. I feel like the same in the sense that I made a lot of connections this year. But I kind of didn't get too much done up until recently. So like you said, you've started to things to start to ramp up. So the last month or two I've done nothing but research, it feels like. But up until then, for the last year, it was like just communicating in my work and meeting all these people in my field and presenting to them and traveling. So it's funny how it comes in waves. I guess you have like a wave of like you get a bunch of work done and then you publish it or you try and publish it, and then the next wave is like now you have to go around and talk to people and see what they think and see what you should do next.
Yeah, no, I guess that's a big part of research and being a scientist is putting something out there, getting feedback, putting something out there, getting feedback, and seeing what else is going on. Another exciting thing this year that was just approved, I think last week or 2 weeks ago, I'm fully funded for next year, which is excellent, from a public-private partnership with a company that's run by, well, adjacent to 10 Tree, which is a big company in Canada that essentially plants 10 trees for every clothing of item that they sell. So I'll be working with them to make measurements on their tree plantations in different parts of the world. And when I can talk about it more, I will certainly be insisting that we do an episode on it. But
Of
for
course.
now, there's a lot of exciting things going on, and it's also nice to be fully funded because then you don't have to TA as much, and it's less other work, and you can focus on research.
hmm Maybe I should try and like convince Duncan to fully fund me. I think he has a few students who he got at least one or two students next year who are leaving because they're finishing. Maybe I can be like, hey Duncan, you got some extra cash? No, he would just hire more people. Honestly, I don't think he'd do that, but which is fair enough. I wouldn't either, right? Like I'd rather have two than one. So
Well, I think next thing we could talk about is the future, right? So this upcoming year. Well, actually, one thing I actually never done, I never thought of doing is having the New Year resolution. But anyone have any goals in mind for the next year or so?
I completely out of pocket, but I want to do some more thrift shopping. That's my New Year resolution. I was at a Value Village the other day, and there were some like like I've gone thrift shopping a few times in my life, but Value Village the other day, there was like some wicked things that were basic. There's like a lot of coats that are like you'd buy them at a nice store for like $200, but they're in Value Village for like $10. It's crazy to me. It's like, wow, like I should be going here every week, honestly. This is awesome. And I think I'll up my fashion game a little bit, you know. I can make like a full outfit there for like $30 or something. It's crazy.
90% of my winter clothes are like passed on from, let's say, my friend's family that like they don't use them anymore and stuff. Like so, like the sweater I'm wearing right now is my friend's mother's old sweater. So
All of my winter clothes are just the same ones I've had since high school, basically. Because like I bought like a pea coat, and it's not like it deteriorates rapidly, and like you need to replace it. So I've been wearing the same. I have 2, 3 winter coats, but like the main one I wear because it's the one I care the least about. So if it gets damaged, like I'll just wear it day to day. If I'm going somewhere nicer, I'll wear my nicer coat. But this one coat I've been wearing since like 2013 or 14 or something like that because it's just a good solid coat. But it'd be nice to have some variety, I think, because like I'm starting to like, you know, the more professional you get, you're like, all right, I can't just wear the same things every day. I gotta like impress people and network and blah blah blah. So I don't know. I like dressing up too, so I'm kind of tired of just wearing the same 2 coats all the time. And I think some thrift shopping would be nice. Um, and I guess more physics oriented. um, Feely, you and I and Dean are working on our own publication, which I will not get into yet. But it's the kind of the first time I've been working on something on my own because the publications I work on now, they're all kind of like under supervisors. Where this one is just me, you, and Dean working on it, and it's kind of almost done, honestly. So we'll see how it goes because I've never tried publishing something without someone who's experienced in the field. So I think we're gonna have to talk to some people, but I'm excited for that. In the new year, we'll see how that goes. It'll be a learning experience for sure.
Yeah, I've been watching the talk between you guys about that paper, and I'm excited to see it eventually published. I know it's been a long time coming for the 3 of you, just since undergrad. So yeah, it'll be cool, and when we can talk about it too, that'll be fun to hear.
Yeah, I don't think it's a life-changing publication in all honesty, but I think it's enough that it's like worth publishing, and it's some work we did during our undergrad together in like 2017, and Dean randomly called me one day about it when I was he randomly called me one day and he was like, if we combined all of our notes on this, like we'd probably have enough for a publication on it. And I was like, oh yeah, that's a good point, man. So thanks to Dean for remembering this, because I kind of just figured, I was like, this work, like there's no point ever pursuing it again. And I just had a couple files saved deep in my computer somewhere on it, so we dug them all up and we compiled them. And I think I've done nothing but work on this paper for the last month. And I'm excited to kind of get it out of the way and done with. But it was kind of a cool learning experience, just working on something on my own. Well, with Feely and Dean, of course, but like without some established researcher giving you input on it. So I had to go and like do a lot of research on my own that normally I would just ask someone, like, you know this field really well, like point me in the right direction. But I've had to spend a lot of time like scavenging the internet.
yeah, so I guess that's gonna be one of our goals next year to finish up that paper.
It's almost done. Like, I know you've been pretty busy, so you haven't had you haven't worked on it too much, but Dean's worked on it a good amount, and I've done a lot too, and it's like 80% done at least, I'd say.
Yeah, after the next couple months, I can look into it. I think one of the thing. Well, I still have some requirement to do for my program that I need to do the next couple months, and after that, I'll be able to take a more closer look. And I think that's gonna be one of my main goal is to really finish what I require to do for my program next year, so I can not even relax, so I can really focus solely on my research and to try to finish our PhD. I think I'll try to survive the next year, right? And there are
That's
a couple
always the
other
goal.
goals I have too, right? In terms of my life and well-being and stay connected with people. I think to me is a very important thing. It's getting a little harder and harder the further along that that we are far apart, especially our old friends. So I've been calling people and try to keep in touch. It's been more difficult, I think, the past year, but I hope to continue that next year.
I also hope to really delve into research and really get focused on that. I still have my candidacy or comprehensive exam to do. So not looking forward to it, but looking forward to finishing it, which is a huge requirement for the PhD. And some people have said that it's even more, I guess, important and challenging than the final defense, because by then you know what you're talking about, whereas this one you have to prove you know what you're talking about. So hopefully getting that done early in the year and just being productive with my research and on the same vein as Liam, also productive with my bagpiping.
Yes, that is my goal as well. I don't know if I mentioned that one for my future, but that's like kind of built into my future. It's always there that I want to get better at it, and I'm working at it. So many New Year's resolutions, but I think they're achievable.
All right, I think we have pretty good discussion. So unless anyone have concluding remarks, I think I can. Well, 2023, I think we all of a similar age. I think we have grown up a little bit, right? And each year, I think not I don't feel as different as when I was in, let's say, undergraduate, in those more rapid change in our mind. And I think we have matured quite a bit, and we have quite a few episodes of the Hyperthesis out for this year, which is, I think, is great. Is one opportunity to keep in touch and also keep track of what's going on in science world, to be able to discuss it and have some guests over. I think we've been very fortunate and have quite a few. Like, we have many guests this year, and they're quite memorable. And I'm glad to be able to hear their life story and how they get into physics, and also more about their research and how people describe their research, their passion about it, especially when they're doing graduate school, right? Is a commitment they make, and to be able to hear why they are interested and how some of those projects are very impactful into our daily life, and some of them are very impactful in our search for the truth of the world in the science world. And I think it's a very fascinating year for the Hyperthesis overall.
We had 12 guests this year as well, so that's one per month on average. So that's pretty good. We're always trying to get more. So if you're interested, definitely listen to what Patrick is about to say.
Yes, we have had 12 guests this year. It's been an exciting year. We've also done a lot of work apart from the actual show itself. So you can check us out through many different ways. One is our Instagram. We are at the Hyperthesis, where you can check out updates for when we're posting episodes, and also updates between when we have breaks. We do have breaks. We are students. We like to take a little bit of time off from recording a couple times a year, which we were also good to do this year, but still stayed on track. So you can find us on Instagram at the Hyperthesis. You can send us an email. We are hyperthesispodcast@gmail.com. So you can send us an email if you have questions, comments, if you have topic suggestions, or if you're an expert in your field. We would love to hear from you. We love having graduate students on, especially. So if you're a graduate student and would like to be on the show, or if you're anyone else, but as long as you are an expert in your area of science, or maybe you don't feel like you're an expert, but you actually are, we would love to have you on. We are also on YouTube. We did a great job this year of keeping our YouTube updated and getting that going. Did we start YouTube this year? We may have started this year, but we are pretty much caught up and consistently uploading. We have, I think, well over 1,000 views now on YouTube, which for 60-some videos might not sound that great, but it's good for us. And feel free to share us, like, subscribe, comment, do whatever you need to do on YouTube to get the word out and listen to us. We are also on pretty much whatever podcasting service you listen to, whether it's Apple Podcasts, Google Podcast, which again is becoming part of YouTube Music soon, Audible, Spotify. We are based out of Spotify. So however you get your podcasts, feel free to share us, give us a rating, even just like a quick comment of what you think of the show, or if you have suggestions for topics in the new year. We would love to hear from you. Reach out to us, listen to us, and share us.
Thank you very much, Patrick.
All right. And with that, I will see you guys next year. And let's have a great hyperthesis year next year too. All right. Take care.
Bye, everyone, and Happy New Year.
See ya.